Hello and welcome to dear lecturer. Okay, now I have to present about Bode Plot in Black 4 control system. Okay, firstly we want to see the exercise given. So I had made we make the calculation, and now we get 104 squared plus 4l plus 1. So by calculation I get the gain margin GM equals to negative 20 decibels. Phase margin equals to negative 63 degree. Gain crossover frequency equals to 0.5 radian per second. Phase crossover frequency equals to 0.1 radian per second. The actual value of the simulation from the simulation we get I get gain margin of 20 decibel, and the phase margin equals to 68.2 degree, and gain crossover frequency equals to 0.5 radian per second, and the phase crossover frequency equal to 0.0964 radian per second. Next, we write this all the command, and we get the board diagram. We can see this is for the board diagram. And GM equals to 20, PM equals to 68.1713, and we get this amount. And next, for the procedure, we get the function. So okay, for frequency we get 0 decibel starting point, and for phase we get starting point of negative 90 degree. And this is the graph I made, frequency versus magnitude. You can see the graph. Okay, and this is also a graph I made. For the positive margin gain means how much gain can be increased by the control system, when negative margin gains mean now how much gain can be decreased in the control system. The control system should therefore follow the negative and positive benefit in the step margin in response to various uncertainties. So for the exercise 4.12, when k equals to 100, so we get the board diagram. Gain margin equals to 35, the phase margin equal to 95.9, and the frequency we get 17.5 radian per second, and the delay margin we get 2.48 second. And when k equals to 50, we get gain margin equals to 41, and phase margin equal to 94.5, the frequency 17.5, and delay margin 5.332. Okay, for k equals to 500, we get the gain margin equals to 21 decibel, phase margin equals to 56.9 degree, and gain margin, the delay margin equals to 0.234 second. The frequency is 17.5 second radian per second. Okay, when the k increases to 1500, the gain margin equals to 11.5, and the phase margin equals to 26.5, delay margin equals to 0.0533, the frequency 17.5. So this for exercise 4.1. This is I do the calculation how to get k equal to 100, k equal to 50, k equal to 500, k equal to 1500. In this lot we get to use the Bode plot. So Bode diagram to determine the stability, which is closed loop system, frequency system, and use MATLAB to provide a Bode plot for an unstable system. Since an unstable system does not react sinusoidally to a sinusoidal input, such an input should not be interpreted as frequency response. So in mathematically, an unstable system impulse response is not an entirely integrated signal and resulting Fourier transform does not converge. Okay, for the conclusion, using mathematical software is simpler to make Bode plot, but it is more useful to factor the transfer function into simpler zero pole type to remove characterization from a Bode plot to assist circuit design. The inverted zero poles are sometimes able to simplify variables and help designers understand the circuit better. A pole zero plot offers more data than the just stability, making it possible to understand what the system answer would be from the poles. That's all. Thank you.